Let's check out this guy right here. So we want to go ahead and find the domain and range of this function of the square root of x minus 4. And I want to do this both algebraically and graphically. So let's first go ahead and pull out our graphing utilities, and we're going to do this together here. So if I go a little fast, you can just pause it and rewind it right here. Okay, so go ahead and press y equals, and now we're going to be able to put in our equation. So we're going to go ahead and do second square root, and so basically right here, which is nice because it kind of tells you what I just pushed. All right, so you're going to do the second button square root, and I think that was what, like x plus 4? I should know that there. Yeah, like x minus 4. So we'll do, and again, like use this button right here for x, and then minus 4. Okay. What I want you to do is press the zoom button, and we're going to do a standard window. Okay. And so make sure that you press zoom and then press number 6, and then that's just going to give you a standard window. Standard means that it's 10 on the positive x, 10 negative x, 10 positive y, 10 negative y. Okay, so this is what your graph will look like. All right, so just by looking at this, we can be able to determine some of the things about the domain and range here. Okay, first of all, let's look about the domain. Okay, now it seems that this graph is going to go on forever to the right, but let's just see if that really is the case. You see how this only goes up to 1, 2, 3, 4, 5, 7, 8, 9, 10. Let's make the x-axis go out to 100. So the way you do that is you press the window button, and then see right here where it says x max. So let's change that to 100, and then go ahead and press graph. And see what the graph just did was now this entire x-axis goes up to 100, but this is still 10 and negative 10. But see how this thing just keeps going up and up and up and up. It's going to keep going, right? So this information is very important to us when we're trying to think about what the domain and what the range is. So I'm just going to take a little snippet of this real quick, and I'll bring this to our little guy right here. All right, so here's our graph. I'll make this a little smaller here. All right, so this is our graph right here. All right, and just by looking at the graph, we could actually determine what the domain is. Okay, and that's what I want to do with you right now. So the domain means what's the smallest x value, and then what's the biggest x value that this uses, right? Well, the smallest value right here, we saw that right there was 4. That was 4 right there. And the graph showed that. And if you wanted to go back to the graph and look at that again, you can. Let's go back and go to zoom and then press 6 again. And then see how it starts at 1, 2, 3, 4. See how it starts at 4? So I know that we're going to start at 4. We're going to start at 4, and then it's going to go from there. So the way that we can write our domain is we can say it's the set of all numbers x such that x is greater than or equal to 4. Okay, and you can see that there. See, it starts at 4, but then you're going to use all these values here because look, there's a point there, point, and it just keeps going right there. And the range, check this out. Well, what's the lowest y value that this goes to? The lowest y value. Well, the lowest y value is going to be 0 right here, and then it's just going to keep going up and up and up and up because as this thing gets bigger and bigger going up, the range just keeps getting bigger. So it's going to be the set of all y values such that y is greater than or equal to 0. Okay, and again, you don't have to do both notations, but just to show, we could have just done bracket negative, actually positive 4. Let me fix that error. So we're going to do a positive 4 and then out to infinity. And then right here, we could have done started at 0 and then it goes up to infinity. Okay. All right, so that's how you do it graphically. All right, and not that there's one more superior than the other, but the thing is that we can't always rely on the graphing calculator. You actually have to be able to do these with and without. So it is great skills to be able to use the graphing utility to be able to maneuver your way through it. But now what I want to do is I want to do the same problem, but I want to do it algebraically. Okay, and algebraically means without the aid of a graph, we're going to do it all by just using our variables and numbers. Okay, So if I'm going to find the domain now, algebraically, we have to think about our function, the square root of x minus 4. The square root of x minus 4 has restrictions, meaning there are certain values that you cannot plug in to x. So I have a little sad face right here. There are certain values that you can't plug in, and there are certain values that you can. And what I mean by values that you can't plug in, I mean if you were to plug in certain values, you would get a non-real answer, an imaginary answer. And we're only graphing real values here on the real number line. So we're only looking for real answers here. So basically, what has to be inside of the radicand, check this out here, x minus 4 must be greater than or equal to 0. And we should know that, right? Because any value that's negative, any negative radicand would give us an imaginary number. And we don't want any imaginary numbers here. So if I solve for x, I get x is greater than or equal to 4. And as you can see right here, that's where I got this from, you see? If you want to find the range, okay, you have to do this right here now. What is the smallest x value that we can plug in for x? What's the smallest x value? Well, when x equals 0. So if I do f of 0, if I plug in 0, so that's oh, I'm sorry, not 0. The smallest value right here is 4, right? X must be greater than or equal to 4. So if x is 4 then, because that's the smallest value, if x is 4, okay, then let's see what we get. The square root of 4 minus 4, the square root of 0, which is just 0, right? So, okay, what this gives us, since this is the smallest x value was 4, and the output was 0, I know that my range, the smallest value is going to be 0. And then if you want to find out what this is, well, let's think about this. Are there any restrictions to the maximum value that we can plug in for x here? Well, no, right? You can plug in 10, 20, 30, 100, a billion, a zillion. So that means since there are no restrictions to that, then that means we know we're going to go to infinity. Let's look at this guy right now. Find the domain and range. Just by looking at this, you should automatically be able to draw like a little sketch of the graph. And it would have a y-intercept of -1, and it would go down, something like this. I know that's a horrible looking parabola, but it's gonna go down like that. All right. And by looking at that, the domain should be pretty simple because we use all of the x-axis. You see, I use that point, that point, that point, that point, that point, and it's going to keep going to the left. So we use the entire x-axis to the left, and we use the entire x-axis on the right. So we can say from negative infinity to positive infinity. Or you can do the all real numbers. Cool thing right there. Okay. The range means what's the lowest y value and what's the highest x value. Okay. Well, let's see here. Let's look at the y-axis now, right? Because we're doing the range. What's the lowest y value that this graph goes to? Well, it has arrows going down, and since it goes down forever, we know that it doesn't really have a lowest value. So it's going to go all the way down to negative infinity. But then what's the highest value? Like right here, what's the highest y value that this thing will go? Well, that's this guy right here, right? Because that's what that point came from. So -1, bracket, parentheses always for the infinity, and brackets for any closed dot or numbers that are included.